Let's take a look at question number 1 right away. If you look at the question, it says that 3 MHz and 10 MHz were used for transmission and reception, respectively. It's asking which of these different frequencies, when applied, will result in the returning frequency reaching the probe the fastest. Simply put, it's asking which frequency will result in the shortest round-trip time for the signal. This kind of question is easy to solve if you know the basic concept that frequency and the speed of wave propagation are not related. The correct answer is option 1. You can think of all the signals that are reflected and returned as taking the same amount of time. This is a question that tests your understanding of the basic concept that frequency and wave propagation speed are unrelated. Let's move right on to the next question and solve it together. This type of question appears frequently, so I'd like to emphasize it a bit. If you look at the question, it says that a gallstone appeared during the scan. You're scanning with a 3.5 MHz probe, and a situation has arisen where a gallstone is suspected. However, there is no shadowing visible behind it. This question is asking how you can adjust things so that the shadowing behind it can be observed more clearly. Some people might mistakenly think that since a gallstone is mentioned, the question is about something impressive or unusual, but in reality, it's about how to adjust the equipment to better observe this area. That's what this question is really about. I think it would be helpful to remember one rule regarding this. To increase the shadowing of the gallstone, if you increase the frequency, you will see that the related shadowing effect becomes more pronounced. So the correct answer would be option C. This type of pattern appears frequently, so make sure to recognize that what the question is asking is not about clinical content, but rather about the operation of physical equipment. Also, remember well that increasing the frequency is necessary to enhance shadowing. Let's move on and look at the next, question number 3. You can consider question number 3 as a simple memorization pattern. It's also a question that asks about basic concepts. For these kinds of questions, it's more efficient to memorize them through practice rather than focusing too deeply on the content itself. Looking at the question, it involves obstetric ultrasound, and they're trying to improve the image by adjusting various parameters. This question is asking which parameter among them cannot be controlled by the examiner or the operator performing the test. If you distinguish between the options that can be adjusted and those that cannot, the correct answer would be option D. In the case of propagation speed, it is determined by the medium, so the examiner cannot adjust it. Also, what you can learn from this question is that the other options, A, C, and B, are items that the examiner can adjust. Let's move on and look at the next question, number 4. If you look at the question, it explains that Doppler study is being applied to the renal artery. It was measured at a speed of 3 meters per second in the right renal artery. This question is asking which conditions can be associated with the value given here. In the end, although the question looks complicated, it's actually a simple pattern asking about unit conversion. In actual physics exams, rather than complex calculation problems, more questions like this, simple arithmetic that you can solve just by looking, tend to be asked. An example that can be written as 4 meters per second would be the 300 centimeters per second mentioned here. Let's move on and take a look at question number 5 right away. This question can be considered a bit ambiguous. Just take this as a reference and look over the content. They're about to perform a scan, specifically an abdominal ultrasound scan. This expression refers to a thin patient. They're going to examine a thin woman. Also, since other countries use the Galvus unit, it can sometimes be hard to understand, but let's continue with the sentence using the keyword thin woman. If you look at the sentence, it's a question about choosing the frequency that provides the best spatial resolution by allowing better penetration. Generally, a frequency of about 3.5 is used for abdominal ultrasound. But since the patient is a thin woman, if the penetration is too deep, the image may not be formed well, so it's more efficient to increase the frequency to around 5 MHz. However, there is some room for debate with questions like this. The standard for what is considered thin can vary from person to person, and the range of frequencies used can differ between institutions, so this isn't really an ideal pattern for a question. In fact, the most common and clear pattern is when the patient is overweight. Questions most frequently ask about the frequency applied to obese patients, and in these cases, choosing the lowest frequency is considered the correct answer. so keep in mind that topics dealing with obese patients tend to appear more often. Let's look at question number 6 next. This question is both important and covers a very fundamental concept. It is explained that the frequency has changed from 3.5 to 5.0. This question asks what kind of changes in swelling occur in such a situation. The very first thing you can observe when the frequency increases is that the wavelength becomes shorter. Therefore, I can say that the most representative change here is the decrease in wavelength. This is a basic concept and a frequently appearing pattern, so make sure to pay close attention to question 6. Now let's look at question number 7. Question 7 is a type where you review concepts through solving problems. Now, in the case of the 8th topic, the power has been increased during the use of ultrasound. So this question is asking which aspects also increase when the power is increased. The answer is number 2. You can see that all the options from A to D increase. When you increase the power, penetration increases, acoustic power rises, the brightness becomes brighter, and the voltage applied to the crystal also increases. So you can summarize from this question that an increase in power can cause changes from A to D. Let's look at question number 8 next. This question is about asking regarding backing. Let's look for clues while reviewing the main text. First, you can look for keywords that help you choose the correct option. This is asking about the thickness at which the half-value layer has half the original intensity. When using a 10 MHz transducer, it asks you to find the explanation that matches the point where the intensity here becomes half. Looking at option A, it explains that a decrease of 3 decibels occurs when the intensity decreases. In ultrasound principles, there's the 3 decibel rule, which means that when -3 decibels appear, the original intensity is reduced by half. Conversely, when the intensity increases by 3 decibels, it follows the rule that the value doubles. So in the case of option A, you can say it's the correct answer. For option B, it explains that these changes occur at a shallower depth near the surface compared to when using an omega-hertz transducer. When the frequency is higher, penetration is shallower, so the phenomenon of intensity decreasing can occur at a shallower depth than with omega-hertz. Next, number 10 is a sentence that defines the HBL. You can think of the HBL as the point where the V-min test decreases by half. So I can explain that the correct answer is option B this time. This problem as well is a pattern that allows you to organize the overall concepts through solving the questions. Let's look at question number 9 next. Since this is a basic question, let's find the answer right away. It is asking about the propagation speed that should be measured in an ultrasound phantom. Since the reference value is soft tissue, the standard value can be considered as 1,540 meters per second, which is option C. Next, let's move on and look at question number 10. For question 10, you just need to have a general understanding of the content as a reference. Let's look up the relevant information through solving the question. This question is asking about the factor that determines the frequency in pulsed ultrasound. The correct answer can be considered as option D. Options B and C can be seen as the 2 factors that influence the determination of frequency. You should know that the frequency is determined by the propagation speed of the piezoelectric material and the thickness of the piezoelectric material. Once again, the 2 factors that determine the frequency are the propagation speed and the thickness of the piezoelectric material. Just refer to this information as a reference through the question. With this, we've solved up to question 10. Next time, I will continue to explain the remaining questions. This concludes the lecture. Thank you.